Good morning. This presentation refers to the TEL project addressing medium and low voltage electric powertrains. We have 5 partners: Infineon, Valeo, IFES, Dana, and the University of Surrey. The coordinator is Herbert Parish. The presenter is me, Pietro Perlo. After presenting the objectives we have in the project, I will immediately pass to describe the results, focusing on powertrain, vehicle control, vehicle development. We developed 2 vehicles. We will also try to respond to the 3 questions posed by the organizers in terms of what is the plan for the future, how far are we from the market, and what was possible thanks to the financial support of the European Commission. We have specific objectives in terms of efficiency of the electric motors that are based in our case on synchronous reluctance machines, efficiency at both voltages of the inverter technology, and addressing security in the partitioned electrical and electronic architecture, and again, in terms of vehicle development, safety and affordability. We are addressing 3 main sectors: the small and medium segments, mild hybrids, and lightweight urban mobility. In terms of result, let me start from the motor and inverter. The inverter is particularly high efficient with the peak efficiency of 98%. But what it is very important here is that we have an average efficiency of 96% at very low speed, because we are addressing primarily urban mobility. Similar performance is also in the electric motors, where we have 96% efficiency at a very low speed, which is the state of the art. Why we are focusing so much on the 4-wheel drive? Because there are several advantages. Here we have improved acceleration and improved climbing performance, improved energy recuperation, and also excellent fail-safe properties. Having 2 identical axle systems, we have a sort of ideal mass distribution, but what it is also very important is that we have an active control of the front to total wheel torque distribution, which is improving the steady state and the transient cornering response. This is particularly important in view of future automated driving. We have control in the 2 axis systems independently. What does it mean? That the simulations and also the real implementation on the road, if we take an example of an IC patch, is that controlling the 2 axes independently from one from the other is that we can limit when we have acceleration in the longitudinal slip. This is an example when the passive, so no control at all, we have a rather large longitudinal slip. Controlling the 2 axes independently, we have a very, very reduced longitudinal slip. Specific publication will be made in a short time on this aspect. In terms of general vehicle performance, the 4-wheel drive allows more than 50% grade slope. We have an acceleration in the 0-100 km per hour in 12.5 seconds, which is quite acceptable in the urban mobility. Very important is also that we have at a constant speed of 30 km per hour, only 3.4 kilowatt hour per every 100 kilometers. Now, in the VLTC cycle, scaled to 150 kilometers an hour, because we have a limitation at 120, we have a total consumption in the cycle of 10.84 kilowatt hour per 100 kilometers, which is quite a good control of the energy consumption. Now we also have a development in this project and the low voltage, specifically addressed by Valeo, for special purpose urban vehicles, together with the IFES in this case, and mild hybrids with motors up to 30 kilowatt. The picture here is presenting a specific motor, indeed at 30 kilowatt, which is water cooled, and on the left side you see the integration on 1 hour axle system. Now, very important when referring to safety and affordability is the way we are approaching the design of the body frame. We can design the body frame in minutes now, after several years of development, of course. And what it is important is that the acceleration, the peak acceleration in a full frontal crash test is in the range of 40 G, which is 10 to 15 less G than what you can find in commercial cars today on the road. Very important when we're addressing affordability is also the fact that what you need to develop this in a manufacturing line is an investment of a few millions only, compared to the 100 and more that you have with a conventional approach. So much faster and much cheaper. In terms of security, there are several approaches possible when you try to upgrade your software via over the air. We are applying a post-quantum classical encryption plus pre-downloaded quantum keys, and introducing also a time gate. We say that our approach to secure the transmission of data is proved against the forthcoming quantum computers, which indeed is also a very simple and extremely effective approach to secure the communications in our vehicle. Now, we developed two vehicles. One is developed in common specifically for the battery pack with the project Demobase that we presented later on in this conference. And then we also developed what we call less than zero emission, as a provocation, of course, in airport and ports, because indeed, in many days, you can produce more energy than what you need for the mission in those specific locations. So the two vehicles have a common platform, which share the body frame, the doors, the powertrain, the battery pack, the ADAS system, and essentially almost everything. This that we also have a 23 MEMS sensing platform for preventive maintenance. So we have two vehicles. The passenger is at 120 kilometers per hour. It has a modular battery pack. We go by layers. We call the lasagna system. Our approach developed inside the Demobase project. And in the iVan, we have 1.1 kilowatt installed of solar panels, which in many locations allow indeed an extra range, which is not so secondary aspect. Now, we were asked what plan we have. Well, there is, of course, a sort of roadmap that started a time ago. We developed several vehicles. In 2020, we have 138 patents granted already. And in the new project that is starting the 1st of December 2020, we have introduced 3 new partners aiming at the development of an affordable L4 automated vehicle and a novel approach to develop safe batteries without BMS and no cooling. Now, there was another question related with the market. Where are we now? Well, let me provoke the system saying that we are ready and we are taking orders now for iVans, this one that you see in the picture. And we also said to the European Commission that at a Chinese-like competitive price, we can sell you 25 vehicles before next edition of this conference. Of course, we are not addressing primarily the production of vehicles. Our real product is the microfactory, And together with our partners, we are proposing this concept with a certain success, I would say. What we say is that the new building and the full manufacturing lines can be operated within 12 months from the order. Well, at least for IFES, which is an SME, everything has been possible only thanks to the financial support of the European Commission. So that what we can say is a big, big, big thank you to the European Commission.